Hello, hello. Testing, testing. Hopefully my mic is on. Bam. I should be appearing. There we go. There I am. Hello, hello. Good morning, or afternoon, evening, wherever you are. Hello. Let me bring up my coding window. Oh, there it is. It popped up on its own. Very convenient. Okay, we're still on our little weird detour on Leetcoding. Previously, we were trying the blind 75, and then we went on a detour with this random Google interview question as suggested by my brother. We tried this problem last time. It took me 2 hours. I was kind of not satisfied with how I did last time. So I want to try this problem again, and hopefully I can do it way quicker in less than an hour, because if I do it in 2 hours in an actual interview, I'm kind of screwed. Okay, let's try this problem again. Second time's the charm. Snapshot array. Implement a snapshot array that supports the following interface. Snapshot array int length, so that's the constructor, initializes an array-like data structure with the given length. Initially, each element equals 0. Okay. Void set index value sets the element at the given index to be equal to the value. Okay, that's pretty standard with arrays, I guess, or lists. Int snap takes the snapshot of the array, excuse me, and returns the snap ID, the total number of times we call snap minus 1. Okay. Int get index comma snap returns the value at the given index at the time we took the snapshot with the given snap ID. Okay, so in the example, they instantiate a new snapshot array with length 3. They set index 0 with 5. They do a snapshot. They do another set, index 0 becomes 6, and they get from snapshot, no, they get from index 0 from snapshot 0. So they will be getting 0, 5. Yes, very tricky. I think it's helpful if we draw this out. Can I draw here? Oh yes, I can draw. Okay, so the naive solution we tried last time was we have a little, well, actually I can draw like this. We have a 2D array basically. Like that. And then the rows are basically your snapshots. Ooh. Snap. Nobody can read that. Fine, good enough. That's the snapshots going this way, and then this is the actual like indices. Index going this way. So for our example over here, you would store, we have length 3, right? So it would be like, okay, the first one is here. We would store 5 here at index 0. And then at index 1, we would store 6 over here. Yeah, and then for the get operation, we would just look up, okay, what's the snapshot? 0, okay, go to 0. What's the index? 5, okay, get 5. Yeah, but as we saw last time, this leads to memory limit exceeded because we store like an entire array for each new snapshot, which is really inefficient. So we need a different solution. Let me get an eraser. Erase everything. What we need to do is, instead of storing a 2D array, we store a tree map. I guess I could explain with the hash map first. So these are the actual indices index is actually going this way. And then for each index, we store a hash map. So then when you, for example, when you set 0, 5, at index 0, you set 5, would map snapshot 0 to 5. So this over here, the key, is the snapshot. Let's see, you make a snapshot. We also need to make a snap number here, like snap equals 0 at first. So then when we do a snap, we increment this. 0 becomes equal to 1. So now when we do a set, like, okay, at index 0 set 6. So now we add a new key value pair with 0, 6. Yeah. And then when we do a get, like 0, 0, we just look up, okay, index 0. Yeah, index 0. What is our snap ID? Oh, I made a mistake here. This should be snap equal to 1 because we were at snap 1 over here. Yeah. So snap 0, it maps to 5, snap 1 maps to 6. And this is a lot more memory efficient. Holy, I can't speak today. This is a lot more memory efficient because instead of storing entire arrays line by line for every snapshot, we only store the numbers that we actually set in each snapshot. So when we do a get operation, we do index. Okay, we're getting from index 0. What snap ID? 0. So we look at, okay, get the key from the hash map that is 0, and that maps to 5. So we return 5, and that should be our answer. Yeah. So this is an array of hash maps. There also could be the case where, let's say for some reason you're on snapshot 2, right? And so you're like, okay, what if you're like, get from index 0, snapshot 2. So then you go to index 0 and you try to get 2 from the hash map, but you're like, oh wait, there is no 2. Do I just return the default value? No, you don't do that because you do have a history of a number here. You can look at your previous index. I guess you can think of it like a snapshot preserves the current values in time, right? So snapshot 2 by default would start off with the values of snapshot 1. So this is where the tree map comes into play. So we aren't actually going to do a list of hash maps. We're going to store tree maps. Tree map, and this is going to be a list of tree maps. So tree maps are basically like hash maps, key value pairs, except it keeps the keys in a sorted format under the hood too. So you can actually sort of binary search the keys. And it is a function called lower key. Yeah, lower key, or like lower entry. There's also lower entry too, returns a key value mapping associated with the greatest key strictly less than the given key, or null if there's no such key. I'll just stick with lower key. Returns the greatest key strictly less than the given key, or null if there's no such key. So we can do the dot lower key. Call that function. So yeah, when we call dot lower key on, for example, snapshot 2, it's actually going to give us the snapshot for 1 and return 6. So that's exactly what we need. So that kind of simulates the behavior of each snapshot taking on the default values as well, each snapshot's default value is its previous snapshot's values. So even if we didn't set anything specific for that snapshot and that particular index, we'll still be able to come up with values for it. And it's pretty space efficient. Yeah, we only modify what we actually set. Okay, that's the plan. Let's start freaking implementing. Before we start implementing, give me 1 second. Sick. Okay, let us start. So snapshot array, what do we do in the constructor? We should set up our data structures, right? So on top we have a Silo from Silo sought tech support reporting in for duty. Oh, hello Silo. Thank you in. Thank you for, I don't know, reporting in today. Welcome to the stream. Hello. We are using a tree map. Have you heard of a tree map? I have not before doing this problem. Tree map, we're gonna map integer to integer. We're gonna call it snaps. And then we should have an int that maps to the current snap is equal to 0. So snapshot array should instantiate these data structures. So snaps is equal to new tree map with integer length. And then maybe I shouldn't instantiate current snap up here, right? That's bad practice. I don't know why that's bad practice, but it is. Maybe it's because it's good to have all your initial values instantiated all in one place so it's easier to debug. Something like that. But yeah, Salo, is it lunchtime for you? What are you eating for lunch? Is that all we have to do for the constructor? Let me try to think. The gears are spinning. I can't think of anything else to do in the constructor. Okay, we'll probably find out if there's something to do. Okay, so now next we need to set a int index with int value. Okay, so I think the first thing we need to do here is we need to actually try to get the tree map at the specific index that we're going for. Yeah, and if there's not one, we need to actually instantiate a tree map and then put it in. And then we can safely try to put our snapshot map to the value. Yeah, that's the plan. Silas is in 20 minutes. IDK, what's in mess today? Oh, you call it mess, not the cafeteria? What do you usually have in mess? I'm so curious. In India college, right? What's your favorite food in mess? I'm trying to remember what was mine. I think we used to have this like rice and beef thing. Though I think beef is kind of not popular in India, right? I used to like putting sriracha over rice and beef. I thought that was pretty good. Sriracha goes well with anything. Okay, first things first. Tree map, integer. Okay, what do you call this? We'll call this, no, not index. I don't know what to call it. Tree map is equal to snaps.get the current index. And if t is equal to null, then that means we have to instantiate it. So t dot t is equal to new tree map. Can I just do this? And then we have to put into the array too. So snaps dot put. Wait, I just realized this is a array, not a list. So we should do bracket notation here. Yeah. And then snaps index is equal to t. Yeah. Salo says, well, I'm a vegetarian, so I probably have potato today. Let me check. Oh. How are the potatoes cooked? Do they just give you a whole potato on a tray and be like, good luck? Is it mashed potatoes? Diced potatoes on salad? What else can you do with potatoes? Curry? Yeah, you can put in curry, right? My mom does that a lot. I promise you I'm not being racist here. It's a real thing, I swear. At least the way my mom does it. Okay. Snaps t is equal to new tree map. Snaps index is equal to t. We should be good on that end, right? And then t dot put the current snap map to the value. I think it's a good time to do a sanity check. Let's do, for the rest of the functions, let's return bogus values for now. Int get return -1. Yeah, let's make sure our constructor and set is even working. Like, do things even compile? No, they do not. Incompatible types. New tree map length. Tree map cannot convert it to tree map. Do I need to put a type here? Like integer, comma, integer length? No? Generic array creation. Okay, time to ask ChatGPT. How to make array of tree maps in Java. I feel like I should write this down. I had trouble on this last time too. Okay, so the syntax is new tree map and your length. Wait, that's exactly what I'm doing, though. Hold on, let me just write this down anyways. Array of tree map is new tree map length. Okay. Salad says we got mixed salad, kata veg, dal tada, tadka, plain rice, chapatis, roti, pickle, buttermilk. Oh, that sounds not bad. What do you think of that? Is that supposed to be good? Oh, I see how it is. Tree map, integer. I did not put this as an array. So new tree map length. Okay, that should be good. Take that, Leetcode. Hey, yeah. Okay, it compiled. Let's go. Set. Can we print what our snaps look like every time we set something? Maybe that'll help us. System.out.println arrays.toString the current snaps. Sure. Take that, Leetcode. Okay. Ooh, wait, this is good news. Okay. So three indices, right? In the first set, we set it 0, 5 and then 0, 6. Okay, perfect. So set, excuse me, set is working perfectly. Okay. Next up, we need to increment snap. So all we need to do here is return, hold on, current snap ++, right? Returns the snap ID, the total number of times we called snap -1. So the first time we call snap, we return 0. Okay, so return current snap. You know, I could just do current snap ++. It's going to return the current value and then ++ it. Wow, I is a genius. And then for get, we need to... Okay, we gotta be careful here because there might not even be a tree map at that particular location, right? So we gotta do something like this again, like similar to this check. We first actually try to get the tree map at that particular index. If it's equal to null, then we return 0 because that's the default value. And then we try to get our best key at the current tree map. So integer best key. I'm doing integer because it could return a null, the function I'm using. I'm doing the lower key function. How do I use it? Lower key. You pass in the key, and it returns the greatest key strictly less than a given key, or null if there's no such key. Integer best key is equal to... Maybe I should make this smaller so people can see. Integer best key is equal to the current tree map dot lower key, pass in the snap ID, and then hopefully it should return the value. So if the best key is equal to null, meaning we don't have a specific snap for that, we return 0, or like meaning there's no snaps below it, right? So we return the default value, and then else you return a actual fetch from the tree map. So t dot get best key. Sally says, I'm off, have fun. I got a math assignment to do. Oh, good luck. Yeah, have fun at lunch. Good luck on the math assignment. It's get, right? The function is get. Yeah, it's get over here. Maybe I should actually write down some functions from tree map. Tree map. You can't see, but I'm scribbling in my notebook. Tree map. So it's basically like a hash map, right? But with an extra lower key function, which is kind of useful. Cool, okay. Return t.get best key. That should be it, right? Nope, okay. What happened here? So we're returning 0 on the get. Why are we doing that? Hold on, let's think for this. Let's think for a bit here. So what exactly are they calling here? They're calling get 0, 0, which means the index 0 at snap ID 0. And then lower key we're calling lower key on snap ID exactly, which means we're passing 0 here. Wait. I think I know what's going on. How does lower key work again? Lower key. Where the heck did lower key go? Oh, here. Returns the greatest key strictly less. Okay, it's strictly less. Strictly less. So we're passing 0 here. There's nothing less than 0. But we're trying to get 0 exactly. So maybe we can do a snap ID plus 1. So in this example, we would be getting get 1 dot lower key 1. What's less than 1? 0. So we only can get 0 here. That's probably the solution, right? Take that. Oh, let's go. Please, I'm begging you, work. No, output limit exceeded. Oh, I have some print statements, don't I? Here. Do I have any other stuff? No, okay, I'll submit again. Please. Let's go, we did it! Oh, how long did that take? 33 minutes, okay, that's fine. Last time we spent 2 hours on this. Oh, that's how much improvement is this? 75% improvement? Yeah. Oh, Jesus. Should we try another problem? Maybe let's try another review problem. Leetcode 75. Longest common subsequence. Should we try this? I think I marked this down as a review problem too. I may have done this twice already, but I don't remember a thing as usual. Should we do this? Return the length of the longest common subsequence. If there is no common subsequence, return 0. Oh no, we didn't do this. Twice, I think. A subsequence of a string is a new string generated from the original string, with some characters can be none, deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE. A common subsequence of two strings is a subsequence that's common to both strings. Okay. Okay, I have an inkling of how to do this problem. I think I have a vague memory of how to do this. So let's reload Sumo Paint again. Create. Yeah, we definitely did not do this twice. I would be way better at this if we did. Okay, what do we do here? Return the length of their longest common subsequence. Subsequence meaning we can delete elements, but we need to preserve their order. Yeah, okay. Longest common subsequence is ACE. Yeah, so you delete B and D. Okay, so this is some sort of recursive problem. We definitely need to iterate through both of these texts, right? So we probably need to store the indices of both. Longest common subsequence. Okay. I'm trying to think of the base cases. Let's say our recursive function is what do we get? T1, which is text 1. T2, which is text 2. Maybe we have I, which is the current index at T1, and then J, which is the current index at T2. Longest common subsequence. I guess we can kind of think of this as what's the longest common subsequence starting at I and J? So a base case would be if either I or J are out of bounds. Let's say oob. Then you return 0. Because starting at a out of bounds state, there's no way you can make a subsequence that they both have. Okay, what's the recursive case? So if the current letters at I and J are the same, then it's kind of a no-brainer, right? You should use them definitely, and that's a +1 to your current subsequence. So if T1 I is equal to T2 J, then you return 1 plus, that plus sign is way too wide, 1 plus recursive call to T1, that's the same, T2 is still the same, and then you increment both because you've just used both of these characters. I plus 1, J plus 1. Barely have enough room, okay. And then if they're both not the same, you kind of have two choices, right? You can either increment I increment j. You could increment both, but that case would be covered in future recursive calls. Like you could increment I first, and then you could increment j. That would be the equivalent. So then you could be like, find t1, t2. Let's do an I plus 1 for now, and then j is the same. You just keep trying stuff. Or these are the same, I, but then j is plus 1 here. Yeah, and then you find the max of these two, right? Your goal is to find the longest common subsequence, so take the max of these. Cool, we have a plan. Let's start coding. Okay, we definitely need a helper function for this. So I'm just gonna copy this whole shtick here. I'm gonna rename this whole thing to helper. So we have t1, text1, text2, and then we have int I, int j. So if I is greater than or equal to text1 dot length, or j is greater than or equal to text2 dot length, meaning either is out of bounds, you return 0 because that's your longest subsequence you can make starting from an out of bounds state. Else you start to do your recursive calls. So if text1 dot character at I is equal to text2 dot character at j, then it's kind of a no-brainer, right? You have to use this pair of characters in your subsequence. So return 1 plus also a call to the helper function, text1, text2, I plus 1, I plus j, since you've used up both of your characters here. Else, you kind of have two choices. Int would be to increment I, that's your first choice, is equal to... Oh, I just realized I made a mistake here. It's j plus 1, not I plus j. So you would copy this shtick here. This is the case when you only increment I and look for more common subsequences starting from there, or you increment j. So j is plus 1 here, I is still the same, and then you take the maximum of these two options. Return map.max increment I, increment j. And then in the main function here, you would do return a call to helper with text1, text2. I and j both start at 0. That's your starting point. Submit this boy. What's going on here? Oh, I have an extra bracket, I think. Cannot find symbol int. Oh, I spelled int incorrectly. Please. Yeah, let's go. Please worked. Cool. So we got our basic recursive case down. Okay, I know full well this is probably not going to work when we submit it. We're probably going to get a time limit exceeded, but that's okay. We're going to use that failure and then get stronger from it. What doesn't kill you makes you stronger. A wise woman once said that. Okay, this case. It's time to do some caching or memoization. So the only inputs that change are I and j. So we probably need to store some sort of 2D array that stores I and j. Do I need to watch out for index out of bounds stuff here? they both start at 0 and they both keep incrementing, so I probably don't need to start or like check for -1 cases like in previous problems. That's probably not an issue here. So the cache is going to store the results for each combination of I and j. So I don't have to see these recursive calls here keep branching off, and they're going to look at a lot of the same inputs eventually. So yeah, we're going to turn this from, I don't know, how much does this branch out? Is it like 2 to the power of n? Yeah, we do 2 recursive calls per frame, right? So yeah, probably 2 to the power of n time. There's 1 frame first, we branch off to 2 frames. Both of the frames branch off to 2 other frames, so 0 or 1, 2, 4. Yeah, it's to the power of 2. So yeah, memory is going to be to the power of n, but through this caching, we're going to just reduce it to the number of combinations of I and j. So I guess if each text1 and text2 are length n, on average, it's going to be n squared memory. Wait, what's the runtime for this? We have to calculate the result for each combination of I and j. So it's also n squared time. Yeah. Cool. Previously, I think it's also 2 to the n time 2. Yeah, that's pretty terrible. Okay, it's caching time. We're going to do a 2D array called cache. I think we're going to do it down here because up here we do a out of bounds check, which will help us. So then down here, we don't have to worry about out of bounds. So down here, we're going to do a cache check. So if cache I and j are not equal to, I think we're going to set -1 as our bogus value for now. So if we've already have a result here and it's not -1, return cache I, j. Yeah. And then down here, we should store the result in a variable first, so then we can store it and then return it later. So result is equal to this. Oh wait, there's 2 types of results, huh? You know what? Let's do int result is equal to -1 here. And then result is equal to this, or else result is equal to this whole shtick here. Result is equal to this. Wow, we're already doing some optimizing. Okay, so by the time we get to here, result is going to be either this or this. And then before we return the result, we got to store it in the cache. So cache I, j is equal to result. We do not spell cache right. And then we return freaking, no, not the cache, result. Yeah, that should be it, right? Not sure what else to do besides instantiating the cache here. So int cache is equal to new int width size. What should the size be? ij, so text1 dot length, and then text2 dot length. Strings is length, right? It's not size. Remember, it's length. It's probably length. Size is for lists. And then we need to fill our cache with a bunch of bogus values. So for every int array in, I'll just call this row, in cache, we do arrays dot fill the current row with -1, which I agree with myself is the bogus value. Like over here, right? That's how we check if we've actually put any result into the cache. And then we plug the cache into the helper function. We also need to plug it into the helper function here, and then here, and then here. My keyboarding skills are atrocious today. Okay, let's run. Hopefully it works. Let's go. Okay, this is very helpful for us. Submit. All right, let's go. We're on the board. We're at a very shoddy 9%, but hey, we're on the board. I'll take it. It's always like this for recursion problems. It's like, I'm sure there's a dynamic programming solution I can memorize for this. Well, actually, I can probably convert this to dynamic programming. But for me, it's always easier to figure out the recursive solution. Recursive solutions always come more easily to me, and then I'll just memorize it so it becomes top-down dynamic programming, I guess, instead of bottom-up. Bottom-up, for some reason, is always more efficient. Let me see what other people are doing. M, okay, so M is equal to t1.length, N is equal to t2.length, okay. They instantiate their EP array. 0, 0 is equal to 1. Okay. For every int I equals 1 less than M. Okay, so they're iterating 0 through M. Basically the length of t1. And then for every j is equal to 1, okay, then they're iterating through every t2. If t1.character at I minus 1, okay, so if the current characters are the same, I'm not even going to try to think about why they're doing a -1, but if the current characters are the same, then the best solution here is 1 plus, and they increment both I and j. It's kind of similar to what I'm doing actually. Else, you take the max of incrementing I or incrementing j. Okay. I guess they're doing it all in a for loop. There's no need to like open up a bunch of recursive frames. Maybe that's where the quickness is coming from, but I think our runtimes are similar. See, I wouldn't have thought about this in the first place. Like, what would be my initial values even be? You know? Okay, well, sure. It's okay, we solved this problem. Runtime is okay. Oh, well, there's my 2 problems for today. Alright. Well, I'm off to bed then. It's 12 a.m. in my time. Thanks to everyone who came. Yeah, I've been watching One Punch Man again, by the way. I totally forgot how awesome it was. The animation is so good. I love the humor and the facial expressions too. The fight scenes are actually so nice. It's like sometimes it has that very scribbly look to it, which a lot of people attribute to Sakuga. And then there's always those really, like, the character just flying in the middle of the screen, and he comes in and out, bigger and smaller, kind of dynamic looking, and it's really cool. I actually enjoyed One Punch Man Season 2. I know a lot of people did not enjoy Season 2. That was really nice. I definitely think it was not as great as Season 1 in terms of animation, but I've always been a fan of slice of life, so I don't know. I remember I really enjoyed Season 2. Like, I laughed a lot while watching it. Yeah, I'm just more okay with slice of life, I guess. I thought the Torment arc was really funny. Like, I was pretty strangely engaged during those times. But yeah, it's been years since I've watched season 2. I don't remember much of it. I just remember that I like had a good time with it. But yeah, currently watching season 1. I can't wait for the Moomin Rider part. I remember I have such a lot of good memories of that part when Moomin Rider was fighting that demented Aquaman and everyone was cheering for him. Brings tears to my eyes. Rim Drifter says, hey, hello. Welcome to the stream. How you doing? Are you a coder too? Have you Leetcoded before too? Also, your name is Rim Drifter. Is that supposed to mean something, Rim Drifter? What could that be? What could that mean? Rim? Rim? Pacific Rim? A basketball rim? What type of rim is this? Rim Drifter says non-beginner. Ooh. How many... I don't know. How many Leetcode questions have you solved? I don't know. That feels like such a pretentious way of asking someone how far they are, but I don't know what else to ask. Rim Drifter says IDK random name. Oh, okay. Yeah, I was trying to think of what your name could possibly mean, but I couldn't think of anything. Maybe when you... What's with the menu? It looks like you live in a hostel? Wait, what do you mean by menu? It looks like you live in a hostel. What's a hostel? Hostel definition. An establishment which provides inexpensive food and lodging. Like a little, I don't know, bunker which people can live in. Are you talking about my background? So this is my background. I guess it's just kind of raindrops on a very abstract raindrops on a blue background. Yeah, I kind of like it. I think it's very calm and chill and has a very fresh vibe to it. My older background was actually not this. I just got this new background. My older background was this coffee shop, but I think I'm deprecating it because it's AI generated. I don't want to use AI generated stuff, art, you know? So yeah, I'm using this one for now. Oh, are you talking about my desk and little laptop here? It's just a random scribble. Rim Drifter says, well, I'll be going now, bye. Yeah, to be honest, I'm gonna go now too. You caught me at the last minute. I've just solved 2 things. Alright, well, I'm gonna end the stream. Thanks for chatting, Rim Drifter. See ya! Oh, bye, Kuni Panda. Thanks for dropping by.